Hello, welcome. It's Mr. Skis. We're doing some calculus. It's 8:14 p.m. on a Friday. What's better than some calculus? We're looking at free response question number something. Number 3 from the year 2019. There's a chance you're just a random person watching this, but if you're one of my students, we use this question as a test question, and I'm here to review it. So let's see how you did. You can reflect on how you did. All right, so looking at the question, they've given us the graph of f. So not a derivative, but simply the graph of f, which is cool. The continuous function is defined on the interval -6 to 5. That immediately is interesting because the graph doesn't go from -6 to 5, so there is a bit missing. The figure above shows a portion of the graph of f consisting of two line segments, bop bop, and a quarter circle. Whoosh. It is known that the point 3, 3 negative root 5 is on the graph of f. Okay, cool. If Part A, if -6 to 5 of f of x dx equals 7, then find the value of the integral from -6 to 2 of f of x dx. Show the work that leads to your answer. I see these integrals. I see the graph. I know integrals is area under the curve. There's some manipulation of the integrals using properties of integrals that we can do here, okay? So I'm going to write this down and then I'll switch the screen. So they told us that the integral from -6 to 5 of f of x dx is 7, right? But we can split that integral up, all right? We're trying to find, I'll switch my screen in a second. We're trying to find that -6 to -2, right? Well, the thing is -6 to 5 is -6 to -2 added with -2 to 5. We can take this integral and break it up into these two pieces, and regardless, it should still equal 7. If this whole thing equals 7, then the sum of these two parts should equal 7. So this is the thing that we're questioning, right? So do we know what this is? Indeed we do. We can calculate the integral from -2 to 5 because it's literally this region that's on the screen. So this is the thing that we're trying to solve for. We don't know what it is, but let's solve for the integral from -2 to 5. The integral from -2 to 5 means we're looking at the area under the curve. So this is a positive half. This is a negative half. That's a little interesting, but what really matters is that this piece and this piece are going to cancel out because they're the same size and one's positive and one's negative. So this cancels with this and this cancels with that. So really what matters, I'll change colors to pink, is this region here. Well, this is a combination of a square with an area of 1, a triangle with an area of also 1, base times height, 2 times 1 divided by 2 is 1, and then this is a quarter circle, right? So what I'm seeing here, geometrically speaking, is I'm seeing a big square that is 3 by 3 with a quarter circle cut out of it. So the square is 9, and I'm subtracting away a quarter of this circle. And this circle, the area of the circle, pi r squared, 1, 2, 3. The radius is 3, so a quarter of 9 pi. So all in all, 119 1/4 of 9 pi. And I'm going to write that as 9 pi over 4. And that equals 7. Right? So, therefore, this integral equals 7 minus this whole thing. So, the integral from, I guess I don't really need this equal sign here, do I? So the integral from -6 to 2 of f of x dx equals 7 minus, you could clean this up if you want. I mean, adding 9 plus 1 plus 1 is not that bad. That's 11. So, but remember, you don't have to really make it super pretty, right? You don't have to do 7 minus 11. And, if you made the mistake and you didn't distribute the negative to this negative and turned it positive, right? Like, there's a chance you could make a mistake because really the final answer is positive 9 pi over 4 minus 4. But this is not necessary. We can stop here. Stop while you're ahead. Save yourself some time, okay? They don't need to know that you can do addition and subtraction. They really don't care, okay? So there's that one. That one's not too bad. It really boils down to properties of integrals, splitting it up, and understanding that an integral is the area under the curve. Okay, let's look at B. Evaluate the integral from 3 to 5 of 2f prime of x plus 4 dx. Okay. So if we're integrating that, I'm literally just going to integrate it, basically. So let me write that down. That's not too terrible of a question. I'm just going to write it down real quick, and then I'll switch screens. So we just want to integrate it, So what would the integral of this be? It would be, well, I kind of noticed the 2 situation. Well, actually, you know what I'm going to do? I'm going to write this as the integral of 2f prime of x from 3 to 5 plus the integral of 4 from 3 to 5. You see what I'm doing there? It just kind of makes life maybe microscopically simpler, maybe. Actually, no, I don't think it does. I'm going to abandon my idea. I'm going to let's just integrate it. Screw it. So if we integrate it, this is going to become 2f of x plus 4x integrated along the bounds from 3 to 5. So constants, when you integrate, just come along for the ride. And when you integrate f prime, the integral of f prime is simply f. And the integral of 4 is 4x. And we're going to integrate this along the bounds from 3 to 5. Well, that means we do 2 of f of 5 plus 4 times 5. You plug in the upper bound first, and then you subtract, and now we plug in the lower bound. 2 times f of 3 plus 4 times 3. And I'm being careful about this big parenthesis, right? Because when we subtract the lower bound, we subtract both of these terms in the end. So what is f of 5? F of 5 can be found by simply looking at the graph, and f of 5 happens to be 0, okay? So that just goes away. 0 plus 20 minus 2 times f of 3. F of 3, do you remember? F of 3 was given to us. This coordinate right here is 3, 3 minus root 5. This coordinate right here is 3, 3 minus root 5. So f of 3 is 3 minus root 5. Plus 4 times 3 is 12. And you're done. You're done. Stop working, right? We don't care to make this pretty at all. No one needs you to make this pretty. Stop. Okay? Because all it wants to know is what does it equal. Okay? I have the official scoring guideline right here, and I will comment that a point is earned for this right here. You don't earn your first point until you do this. And what have you done? You have integrated and you have used the fundamental theorem of calculus. Integrating is not enough. Actually doing B minus A is what's important, and then your final answer being the second point, okay? And actually worth commenting on the first one, since I'm explaining the key, this right here earns a point. The breaking up of the integral into two pieces earns a point. And then solving for this integral correctly earns a point. And then getting the final answer, which either one of these pink boxes would be the third point. Okay, moving on. Part C. The function g is given by g of x equals blah. Find the absolute maximum value of g on the interval, -2 to 5. Justify your answer. So, if you recall, I'm not going to pull up that document, but if you recall, to find an absolute min/max and to properly justify it, we must use the candidates test. The candidates test says you plug in the beginning of the interval, -2, you plug in the end of the interval, 5, and any critical points in between. Okay? So we're plugging them into what? We're trying to find the max of g. So we're going to plug -2 into g, and we're going to plug 5 into g, and then any critical points. Okay? Any critical points. So this is what I have set up so far, right? I need to find the critical points, but I'm starting to set up this table. Now, the first one is easy because when the bounds are the same on top and bottom, you know the integral is 0. Okay? So there's that. And the second one is not too bad either. Or 5, I should say, is not too bad either because the integral from -2 to 5, you might not realize, or maybe you do realize, that's what we solved for up here. -2 to 5 was 11 minus 9 pi over 4. We already solved for that integral. That is something to kind of soak in and be aware of, that the problems are meant to build, right? They're not trying to make you do like extra math for this problem, right? Like, think about what the point of this problem is. The point of this problem is to know if you know how to do the candidates test. So they're not trying to add to the chaos, right? There are things that are in the problem already that they expect you to use, okay? Now, there are a couple critical points that we must find. So what are those critical points? Whenever this equals 0. Sorry, I take that back. Whenever the derivative of this equals 0. What is the derivative with respect to x of this integral? Well, deriving the integral just cancels one another out, and the answer is f of x. The derivative of this integral is simply f of x. Okay? So, and this is g. Recall that this is g. So the answer key, actually, just so you're aware, I wrote out the function, but that was actually unnecessary. I could have just written g of x. Okay? I could just be writing g prime of x equals f of x. That's what I'm saying, okay? If g of x is this integral, then the derivative of g is simply f. So with that being said, we can find the critical points Critical points are when the derivative equals 0. We find the critical points by setting this equal to 0. And where does f, the function, equal 0? It equals 0 at -1, +1/2, and 5. Well, we already plugged in 5. So the other two critical points are -1 and 1/2. -1 and 1/2. So it's really important to know that when you derive what might look like a messy integral to you, but when you derive an integral, it just cancels out. But the important thing to realize is that because this bound is x, when you derive this integral, the t is becoming x, f of x, okay? So what is g of -1? G of -1 means we're replacing this x with -1. So we want to know what is the integral from -2 to -1 of f. So we look back up at the graph, and what is the integral from -2 to -1? We already jotted that down. It's +1/2. And then we plug in this. What is the integral from -2 to +1/2? The integral from -2 to +1/2? Well, you go back up to the graph. -2 to +1/2. This 1/2 and this 1/2 canceled. We need to figure out the area of this tiny triangle. I kind of ignored it before because I was like, oh, it's going to cancel out with this other one. Well, now apparently it matters because we're trying to get the integral from -2 to +1/2. We know that these two things cancel, a +1/2 and a -1/2, but how big is this triangle? This is a base of 1/2 and a height of 1. So base times height divided by 2 is 1/4. And it's below the x-axis. So the answer, -1/4 here. The integral from -2 to 1/2 is -1/4. And the question originally asked, what is the absolute max? So it appears that the biggest number here is right here, the 11 plus 9 pi over 4. So this is the justification. When the question says justify, your candidate's test with the proper critical points is justification, and then you need to say max value of 11 minus 9 pi over 4 at x equals 5. Max value, yeah, I think that's fine. Yeah, maximum value. I guess we could say of g. Maybe that's better. Max value of g is 11 minus 9 pi over 4 at x equals 5. All right, so the points that were earned there, by the way, 1 point for knowing that the derivative of g is simply f. 1 point for correctly identifying -1 as a candidate. For some reason, it doesn't care if you said 1/2, which is interesting. If you simply said -1, not really sure why they have prejudice against 1/2, but whatever. And then your answer with justification is the third point. Part D. Let's go back to the question and read that. It says to simply find the limit. So kind of random, right? It's like, all right, that doesn't feel like it's really connected. And honestly, I would agree. When I saw this, I was like, well, it seems kind of just out of nowhere, but whatever, we'll do it. We may or may not have to use L'Hopital's rule. If you recall, L'Hopital's rule can be used when it's 0 over 0 or like infinity over infinity. So we plug in the limit to see what happens. So 10 to the 1 minus 3 times f prime of 1 over f of 1 minus arctan of 1. Well, 10 to the 1 is 10 minus 3 times f prime of 1. Do you know what f prime of 1 is? F prime of 1 can be found by looking at the graph. So this is f. What is the slope of f at x equals 1? Well, f is a line at x equals 1. And the slope of said line is up 2 over 1. Up 2 over 1. So the derivative at x equals 1 is simply 2. F prime of 1 is 2 because the slope of the line is 2. Over f of 1, I'm going to go back up to the graph. F of 1 is 1. This is the point 1 comma 1. So f of 1 is 1 minus arctan of 1. Arctan means inverse tan. Inverse tangent of 1 is pi over 4 radians. Because when is tangent equal to 1? At 45 degrees, because sine and cosine are both root 2 over root 2. So sine and cosine are the same, making tangent 1. Anywho, this isn't going to be, we just keep going, right? I mean, actually, we're done. Scratch that, we're done, right? Because we don't need to simplify this. We don't need to simplify this. So really, we're done. If you did simplify it, right, 10 minus 6 over 1 minus pi over 4. So 4 over 1 minus pi over 4. But again, this is the end. And I think that's really valuable to recognize is that if all you have is pure numbers, you're done. Here, we weren't done because we need to solve for f of 1, f prime of 1, and arctangent of 1. But at this stage, now that we've found each of these values, you don't need to simplify all the numbers. If you've just got pure numbers on the page, you're done. That question was only worth 1 point. Probably because they realize it's pretty straightforward. You plug in the number 1 and you see what happens. All right. With that being said, kept it under 25 minutes, which is nice. I hope you enjoyed this problem. I hope you learned some things. I hope you can reflect and be better for it. Thank you for watching, and I'm probably going to record another one. All right, see you in the next one.